Good morning, students. Welcome back to maths class, and the chapter is Principle of Mathematical Induction. Okay, last session we have to discuss the based on the problems of Principle of Mathematical Induction. Already 19 questions are over. Okay, next question is prove by mathematical induction 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 up to so on. Nth term is 1 by 2n plus 1 into 2n plus 3. Okay, check it. N equal to 1, 2 into 1, 2, 2 plus 1, 3. 2 into 1, 2, 2 plus 3, 5. LHS and RHS value is what? 1 by 3 into 5, 1 by 15. Okay, next second n equal to 2, 2 into 2, 4, 4 plus 1, 5. Next 2 into 2, 4, 4 plus 3, 7, second term. Third term n equal to 3, then we will get 1 by 7 into 9. Okay, then prove by mathematical induction. Verify the statement P of n where n is equal to 1. And P of m plus 1 is true whenever P of m is also true. Okay. First you have to apply the given statement P of n. Like P of n is a given statement 1 by 3 into 5 plus 1 by 5 into 7, 1 by 7 into 9 and so on. 1 divided by 2n plus 1, 2n plus 3 equal to n divided by 3 into 2n plus 3. Okay. Next, verify the statement P of n for n is equal to 1. Okay. For n is equal to 1. Here, LHS side, nth term is 1 by 2n. Directly you have to take in 1 by 3 into 5, 1 by 15 also. No. 2n plus 1, 2n plus 3. 1 divided by 2 into 1 plus 1, 2 into 1 plus 3. Okay, whole divided by 2 into 1 to 2 plus 1, 3. 2 into 1, 2 plus 3, 5. 1 by 15. Okay, 1 by 3 into 5. And RHS, n divided by 3 into 2n plus 3. 1 divided by 3 into 2 into 1 plus 3. 1 by 3 into 5. 2 into 1 to 2 plus 3, 5. 1 by 15. Okay, therefore LHS is equal to RHS. Okay, thus P of 1 is true. P of 1 is true. Okay. So that what P of 1 verifies. Next, step 2. Let P of n be true for n is equal to m. Step 2. Let P of n be true for n is equal to m. That is P of m 1 by 3 into 5 plus 1 by 5 into 7, 1 by 7 into 9 and so on. 1 divided by 2m plus 1. 2m plus 1. Next 2m plus 3. m divided by 3 into 2m plus 3. This is equation 1. Okay, step 1, 1 mark. This step 2, 1 mark. Next step 3, 2 mark. Step 4, 1 mark. Total 5 marks. Next, step 3. Let P of n be true for let P of n be true for n is equal to m plus 1. M plus 1. To show that P of m plus 1 is P of m plus 1 is P of m plus 1 and replace through this statement 1 by 3 into 5 plus 1 by 5 into 7, 1 by 7 into 9 and so on and so on. Last term 2 into 1 divided by 2 into m plus 1 plus 1, okay, into 2 into m plus 1 plus 3. Okay, 1 divided by 2 of m plus 1 plus 1, 2 of m plus 1 plus 3 equal to n means m plus 1 divided by 3 into 2 of m plus 1 plus 3. Prove this statement. Okay, and replace m plus 1. Okay, 3 into 2 into m plus 1 plus 3. Now we have to take LHS 1 by 3 into 5, 1 by 5 into 7, plus 1 by 7 into 9, and so on. Last term 1 by 2 into m plus 1 plus 1, m plus 1 previous term 2m plus 1, m plus 1 previous term m plus 1 as it is. Next 2m plus 3 m. Next this step as it is 2 into m 2m, 2 into m 2m, 2 into 1 2, 2 plus 1 3. Okay, you know this 1 by first term is 1 by 3 into 5, 1 by 5 into 7, okay, and so on, 1 by 7 into 9. This previous term 1 by 2m plus 1, 2m plus 3. Okay, next 2m plus 1, 2 into m 2m, 2 plus 1, 2 into m 2m, 2 into 1 2, 2 plus 3 5, 2m plus 5. Okay, now 2m plus 3 previous term, 2m plus 1, 1 by 3 into 5 plus 1 by 5 into 7, 5 previous term 3, difference 2. Next 1 by 5 to 7, 7 previous term 5, 2m plus 3 previous term, 2m plus 1, 2m plus 5 previous term, 2m plus 3. Okay, you know this result already. Equation 1, 1 by 3 into 5 plus 1 by 5 into 7 plus 1 by 7 into 9 and so on. 1 by 2m plus 1, 2m plus 3 is equal to what? m divided by 3 into 2m plus 3. m divided by 3 into 2m plus 3. Last term as is 2m plus 3 into 2m plus 5. Okay, using equation 1. Okay, now 1 by 2m plus 3, 1 by 2m plus 3 is common. LHS is equal to 1 by 2m plus 3 common. Then we will get m divided by 3 plus 1 divided by 2m plus 5, 1 by 2m plus 5. Okay, next 3 into 2m plus 5 is common. Okay, 1 divided by 2m plus 3. 2m plus 5 into m. 2m plus 5 into m. 2m into m, 2m square. Plus 5 into m, 5m. Plus 3 into 1, 3. Whole divided by 3 into 2m plus 5. Okay. And the factors in numerator 2m square plus 5m plus 3. 2m square as is, 5m can written as 2m plus 3m. Okay, plus 3 whole divided by 3 into 2m plus 3 into 2m plus 5. Okay, first two term 2m is common, m plus 1. 3 is next two terms, 3 is common, m plus 1. Whole divided by 3 into 2m plus 3 into 2m plus 5. M plus 1, m plus 1 is common, then you get 2m plus 3. 2m plus 3 divided by 3 into 2m plus 3 into 2m plus 5. 2m plus 3, 2m plus 3 cancel, then you get m plus, okay, m plus 1 divided by 2 into m, 2m, 2 into 1, 2, 2 plus 3, 5, then you get 2m plus 5 equal to RHS. This is equal to RHS. M plus 1 whole divided by 3 as is, 2m plus 5m written as 2 of m plus 1 plus 3. 2 into m, 2m, 2 into 1, 2 plus 2 into 1, 2 plus 3, 5. 2m plus 5. Okay, equal to RHS. Equal to RHS. Okay, therefore P of m plus 1 is true. P of m plus 1 is true. Step 4 as it is. Step 4. By the principle of mathematical induction, by the principle of mathematical induction, P of n is true. By the principle of mathematical induction, P of n is true for all n belongs to n. Okay, this is the answer. Next question. Prove by mathematical induction 1 into 3 plus 3 into 5 plus 5 into 7, 1 into 3 plus 3 into 5 plus 5 into 7, and so on, 2n minus 1 into 2n plus 1. 2n plus 1 is 2n minus 1. 1 in order, 1 into 3 plus 3 into 5, n equal to 1, 2 into 1 to 2 minus 1 is 1. N equal to 1, 2 into 1, 2 plus 1, 3. Okay, equal to n into 4n square plus 6n minus 1 whole divided by 3. N into 4n square plus 6n minus 1 divided by 3. For all n belongs to n. For all n belongs to n. Okay. So LHS and RHS value is what for n is equal to 1. 1 into 3, 3 is the answer. LHS and RHS value. Now second term check it. 2 into 2, 4, 4 minus 1, 3. 2 into 2, 4 plus 1, 5. N equal to 3, 2 into 3, 6, 6 minus 1, 5. 2 into 3, 6 plus 1, 7. Okay. Now first apply the given statement. P of n 1 into 3 plus 3 into 5 plus 5 into 7 and so on. 2n minus 1 into 2n plus 1. Okay. N into 4n square plus 6n minus 1 divided by 3. Okay. Step 1. Verify the statement P of n is P of n is true for what? N is equal to 1. For n is equal to 1. For n is equal to 1. Here LHS is 2n minus 1 into 2n plus 1. 2 into 1 minus 1. 2 into 1 plus 1. Okay. 2 minus 1 is 1. 2 into 1, 2, 2 plus 3. 2n plus 1. 2 into 1 plus 1. 2 plus 1, 3 equal to 3. Okay. And RHS n into 4n square plus 6n minus 1 whole divided by 3. 1 into 4 into 1 square plus 6 into 1 minus 1 divided by 3. Okay. 1 into 4 into 1 square is 1. 4 into 1, 4 plus 6 minus 1. 6 into 1, 6 divided by 3 equal to 1 into 4 plus 6, 10. 10 minus 1, 9 divided by 3. 3 into 1, 3 into 3 equal to 3. Okay. Therefore, LHS is equal to RHS. Thus, P of 1 is 2. P of 1 is verified. P of n is 2 for n is equal to 1. Next step plus 1. Okay. M into 4m square plus 6m minus 1 divided by 3. Equation 1. Okay. Next step 3. Let P of n be true for P of n be true for n is equal to m plus 1. To show that P of m plus 1 is 2. Okay, that is P of m plus 1. P of m plus 1. 1 into 3 plus 3 into 5 plus 5 into 7 and so on. N replace 2 into m plus 1 minus 1 into 2 into m plus 1 plus 1. Okay, equal to n is m plus 1. Okay, 4 into m plus 1 whole square. 6 into m plus 1 minus 1 whole divided by 10. Prove this statement. Now, actually, m plus 1 into 4 into m plus 1 whole square. Okay, m plus 1 whole square is what? M square plus 2m plus 1. A plus b whole square. Or another one step. 4 into m square plus 2m plus 1. 6m plus 6 minus 1. M plus 1 into 4m square. Okay, 4 is multiplied by this one. 4m square, 8m plus 4 plus 6m plus 5. Okay, 4m square plus 8m plus 4. M plus 1 into 4m square plus 8m plus 6m. 8m plus 6m, 14m. 5 plus 4, 9. Okay, prove this condition in numerator. Okay, then we get the answer is what? M plus 1 into this 4 plus 4 into m plus 1 square plus 6 into m plus 1 minus 1. Then we get m plus 1 into 4m square plus 14m plus 9. Then we get this is what? RHS one. Prove this result. Now we have to take the lectures. One into 3 plus 3 into 5 plus 5 into 7 and so on. 2 into m, 2m, 2 into m, 2m, 2 into 1, 2, 2 minus 1, 1, 2m plus 1. Next, 2 into m, 2m, 2, 2 into 1, 2, 2 plus 1, 3, 2m plus 3. 2m plus 1 previous term, 2m minus 1. Okay, 2m plus 1 previous term or m plus 1 replace m minus 1 as it is. Next, 2m plus 1, 2m plus 1. 2m plus 1, 2m plus previous term, 2m plus 1. Now, 1 into 3 plus 3 into 5, to do difference, 3 replace 1. This means 2 plus 1, 2m plus 1 previous term, 2m plus 1. 2m plus 3 previous term, 3 next term is 1. Okay, 5 next 3. You know this 1 into 3 plus 3 into 5, 5 into 7 and so on. 2m minus 1 into 2m plus 1 is m square m into 4m square plus 6m minus 1 divided by 3 plus last term as it is 2m plus 1 2m plus 3 using equation 1 okay. Next we'll take the LCM 3 is LCM 3 into next these two multiply m is multiplied by the 3 m into 4m square 4m cube plus m into 6m square m into minus 1 minus m plus 3 into 3 is the LCM 2m into 2m 4m square 2m plus 1 into 2m plus 3 each one multiply 2m into 2m 4m square 2m into 3 6m. Next 2m is over 1 into 2m plus 3 2m plus 3 1 into 2m 2m 1 into 3 3 2m into 2m 4m square 2m into 3 6m. Okay, whole divided by 3 is LCM These two multiply and m is multiplied all the time. Next, another one step. Next 3 is multiplied all the elements. 4m cube plus 6m square minus m. Okay. 4m cube plus 6m square minus m plus 3 is multiplied. 3 into 4, 12m square. 3 into 4m square, 12m square. 3 into 6, 18m. 18m. Next, 3 into 2, 6m. 6m. Next, 3 into 3, 9. Whole divided by 3. Next, separating m cube, m square, m and constant term. Separate. 4m cube. Only one term is there, m cube. Next, 6m square, 12m square, 18m square. Next, minus m, 18m plus 6m. 18m plus 6m is what? 24. 24 minus m, 23m. 23m. Okay. Now this one. Next, only one constant term, 9. Whole divided by 3. Splitting the numerator can be written as 4m square, m cube as this, 4m square plus 14m square. 4m square plus 14m square, 18m square. Next term, m plus 1 is common, converting that. Okay. Next, 23 can be written as 14m. 14 is common, 14m is common, then we will get m plus 1. First two term, 4m square is common, m plus 1. Okay. 4m square plus 14m square, 18m square. Next is 23 can be written as, 23m can be written as 14m plus 9m. 14m plus 9m is 23. Plus 9 as it is. This one also 9 is common, then we get m plus 1. 14 is common, m plus 1. 14 m. Next 4m square is common, m plus 1. Okay. Whole divided by 3. Next, first two terms, 4m square is common, m plus 1. M plus 1. Next two terms, 14m is common, m plus 1. 9 is common, m plus 1. Okay, whole divided by 3 as this. M plus 1, m plus 1, m plus 1 is common. Then we get 4m square plus 4m square plus 14m plus 9 whole divided by 3. This is equal to RHS. Already I am telling 4m square, 4m now m plus 1 into m plus 1 is there. Okay, next 4 into m square plus 6 into m plus 1 minus 1 is equal to 4m square plus 14m plus 9. Okay, divided by 3. There are m plus 1 into, next is 4m square plus 14m plus 9 can be written as 4 into m plus 1 square, 14m, now 6 into m plus 1 minus 1 whole divided by 3. Therefore, P of m plus is 2. This is equal to RHS by the principle of mathematical induction. Okay. Check it once again. 4 into m plus 1 square plus 6 into m plus 1 minus 1 is equal to 4m square plus 14m plus 9. And then telling m plus 1 as is. Now 4 into m square plus 2m plus 1. Okay, a plus b whole square. 6m plus 6 minus 1. M plus 1 into 4m square plus 8m plus 4 plus 6m plus 5. Now m plus 1 into 4m square plus 8m plus 6m, 8m plus 6m, 14m. Okay, plus 5 plus 4, 9. Okay, 4m square plus 14m plus 9. Okay, is equal to, this equation can be written as 4m square plus 14m plus 9 can be written as 4 into m plus 1 square plus 6 into m plus 1 minus 1. This is equal to RHS. Therefore, P of m plus 1 is true. Step 3, step 4 is, by the principle of mathematical induction, P of n is true for all n belongs to n. Okay. Next question. Prove by mathematical induction. 22nd. Prove by mathematical induction. 1 plus 2 plus 3 and so on n is less than 1 by 8 into 2n plus 2n plus 1 whole square. For all n belongs to n. For all n belongs to n. Less than 1 by 8 into 2n plus 1 whole square. First for n equal to 1, 1. LHS. But RHS value is 2 into 1, 2, 2 plus 1, 3. Okay, 3 square. 3 square. 2n plus 1 whole square is there. Divide by 8. 9 by 8 value is 1 point something. This one is what? 1 is less than 1. This is true. P of 1 is true. Check. First solution. Apply the given statement P of n. 1 plus 2 plus 3 and so on n is less than 1 by 8 2n plus 1 whole square. Okay. Step 1, for n is equal to 1. For n is equal to 1. Now this one is inequality sign is there. LHS value is n is 1. RHS is 1 by a 2n plus 1 whole square. 1 by a 2 into 1 plus 1 whole square. 2 into 1 2, 2 plus 1 3 square by 8, 9 by 8 is equal to 1.224. Okay, 1 point something is what? 1 is less than 1.20. Okay, this one is what? 1 is less than 1. Okay, therefore P of 1 is true. Less than 1 by 8 into 2n plus 1 whole square. Therefore, P of 1 is, therefore, P of 1 is true. P of 1 is, next, step 2, same procedure. P of n be true for n is equal to m. That is P of m 1 plus 2 plus 3 plus and so on m is less than 1 by 8 into 2m plus 1 whole square. Equation 1. Equation 1. Step 3. Let P of n be true for n is equal to m plus 1. Okay, to show that P of m plus 1 is true. P of m plus 1 is true. P of m plus 1, 1 plus 2 plus 3 plus and so on, m plus 1 is less than 1 by 8 into 2 into m plus 1 plus 1 whole square. So this statement less than 2m plus 3. This is equal to what? 1 by 8 into 2m plus 3 whole square. Through this statement, m plus 1 is less than 1 plus 2 plus 3 plus up to so on m plus 1 is less than 1 by 8 into 2 into m, 2m, 2 into 1, 2 plus 1 is 3. 2m plus 3 whole square. Through this RHS value. Okay, now we have to take LHS 1 plus 2 plus 3 and so on m plus 1. M plus 1. Okay, m plus 1. After that, apply inequality sign. M plus 1 previous term m. Okay, you know this 1 plus 2 plus 3 plus up to so on m is less than 1 by 8 into 2m plus 1 whole square. 1 by 8 into 2m plus 1 whole square. Okay, plus m plus 1. M plus 1 using equation 1. Using equation 1. 8 is LCM, 8 into 1, 8. 1 by 8 into 2m square. 2 plus m whole square plus 8 into m plus 1. 1 by 8. 8 is LCM. Okay, 1 by 8 into 2m whole square, a plus b whole square, 4m square plus 4m plus 1 square is 1. A square plus 2ab plus b square is 1. Next, 8m plus 8. 8m plus 8. 8m plus 8. 8 is multiplied. 1 by 8 into 1 by 8 into 4m square plus 4 plus 8, 4m plus 8m, 12m plus 1 plus 8, 9. Therefore, 1 plus 2 plus 3 plus 9, so on. M plus 1. M plus 1. This previous content is there. Is less than 1 by 8 into 1 by 8 into 4m square plus 12m plus 9 can be written as 2m plus 3 whole square. 4m square. 3 square is 9. 2 into 2, 4. 4 into 3, 12m. Okay. Now 2m plus 3 whole square. 4m square plus 12m plus 9 means can be written as 2m plus 3 whole square. Expanding this one, 2m whole square is 4m square. A square plus b square, 3 square is 9 plus 2ab. 2 into 2, 4m. 4m into 3, 12m. Okay. 4m square plus 12m plus 9 means 2m plus 3 whole square. Therefore, P of m plus 1 is true. This statement is same as P of n where n is equal to m plus 1. Okay. Prove this result. 1 by 8 into 2m plus 3 whole square. Therefore, P of m plus 1 is true. Therefore, P of m plus 1 is true. Step 4. By the principle of mathematical induction, P of n is true for all n belongs to n. Okay. Next question. Prove the rule of exponents ab whole power n is equal to a to the power n into b to the power n by using principle of mathematical induction. Okay, for every natural number, for every natural number, This one also very simple question. Prove the rule of exponent ab whole power n is, you know this formula, you know, ab whole power n is equal to a to the power n into b to the power n. Okay, ab n equal to 1, n is equal to 1. ab whole to the power 1 is equal to a to the power n into b to the power n. P of 1 is 2. Next n is equal to m. Next a to the power ab whole to the power m into a to the power m into b to the power m. Next n is equal to m plus 1. ab whole to the power m plus 1 equal to a to the power m plus 1 into b to the power m plus 1 is 2. Now ab whole to the power m plus 1 taking LHS, a to the power m plus 1 into b to the power m plus 1. Separately we have to take using equation 1, then we will get the answer. Tomorrow we will discuss this problem. Okay, another 2 classes will finish this chapter. Another 2 classes only. Okay, thank you.